Hi, today we're going to look at quadratic functions and looking at graphs of quadratic functions. And my name is Shannon Seaver, and I'll be presenting this to you. So that's our agenda, defining quadratic functions and graphing them. So I have a graph here of a quadratic function, and I wanted to point out some of the things that you need to know while we're studying them. The first thing you need to know is, first of all, this curved figure here is our actual quadratic function right here. Okay? And then there's some points on here that we want to talk about, and you might want to write these down on your notes. First of all, we want to look at what's called an axis of symmetry. And that is this line right here that is the dotted line. That's the line that actually cuts the quadratic exactly in half. It's kind of the mirror that makes the mirror image of itself on the other side. And it's usually given as x equals something. Okay? So that is important because the vertex is always on that axis of symmetry. Here's our vertex. And also you could say that the vertex is either the minimum or the max of a parabola. In this case, it's the min because notice that the parabola is opening upward. So it's the lowest point on the parabola. But if the parabola was opening downward, it would be the max of the parabola. We also have what's called two x-intercepts right here. And that is where they cross the x-axis. Our x-axis is this right here. I'm going to change my color so you can see what I'm talking about. Our x-axis is, we'll use green, is this one right here. Our y-axis is the one that's going up and down here. And we have one intercept for the y-axis. And that is right here. So we have two x-intercepts. We have one y-intercept, we have an axis of symmetry, we have a vertex. Now, we always have a y-intercept, but there are times that we do not have any x-intercepts. So we'll talk about that later in the future when we're looking at more things having to do with quadratic formula. Okay, so there are three ways of writing a quadratic function. This entire table is something that you need for your notes. So I'm going to go through some of this, but then I suggest that you stop and copy it down into your notes. First of all, we have the standard form of the quadratic formula. Notice it's always in this format. We have f of x equals ax squared plus bx plus c. And you're familiar with that because we've used the quadratic formula and finding the x-intercepts with that before. We also have the vertex here, and the vertex form is a times x minus h squared plus k, and then we have the intercept form where it's x minus some number times x minus another number, and I just use the letters p and q to represent those numbers. So to find the axis of symmetry in the standard form, we're going to use this formula. X equals negative b over 2a. Once we have that, we can find the vertex, because remember, on the graph on the page before, I showed you that the vertex always lands on the axis of symmetry. So I could take that value, the x value, and put it into the formula, the original formula here, to find the y value. So basically, like I said, I'm going to take whatever this is, say it's 2. I'm going to plug 2 in for x and then solve for f of x, and that would be my y value there. My y-intercept is the c value, and that's just this right here. That value alone is my y-intercept. To find my x-intercepts, I need to factor this. I can use the quadratic formula to find it. I can use the box method to find it. But regardless, I need to be able to factor it so that it's back in this format right here, and that will tell us our factors. Our x-intercepts are based on those factors. In just a minute, I'm going to show you each of these methods and each of these forms and show you how to find all these things. Okay, now let's talk about the vertex method. Once again, this is the vertex method. And our axis of symmetry is super easy to find because it's already been found for us. It's that right here. So x equals h. And our k value is our y value. So the vertex is really easy in this case. That's why it's called the vertex form. If I want to find the y-intercept in this, all I need to do is put 0 in for x and solve for y. That will give us our y value. And the same with the x-intercepts. I'm going to set 0 in for f of x, or y, and solve for x. In the intercept form, when we want to find the axis of symmetry, let's go back and look at that. Notice that our axis of symmetry is literally right in between these 2 points of which the x-intercepts are. So if I add these 2 points together and divide by 2, I can find the center. And that's what we need to find. That's why we have the axis of symmetry as x equals q minus p to find the distance between them and divided by 2. So once I have that formula, that x value, I can, like the first one, plug it back in to my original formula to find the y value. I can set x equal to 0 and solve for y to find the y-intercept. And then this one's already solved the x-intercepts for us. It's factored for us, so we know that the x-intercepts are p and q. So this makes the x-intercepts easy to find.